Dear colleagues, let me introduce the report on the topic Development of Methods for Digital Synthesis of Electrical Signals with Normalized Harmonic Coefficient. As we all know, harmonic signals are widely used in radioelectronic and electrical systems in management of alternated low-frequency electrical signals. Distribution of sinusoidal signals associated with characteristics of harmonic signals, of course. And firstly, passage of harmonic signals through linear systems only changes the phase and amplitude of such signals, but doesn't affect the change in their frequency, while new frequency or harmonic components do not appear. Secondly, various complex signals or functions can be represented as a sum of harmonic signals using trigonometric functions. It should be noted that various physical processes can be described using trigonometric functions. When monitoring the quality of electricity in power networks in the frequency range from 50 Hz to 400 Hz, according to regulatory documents, it is necessary to control the harmonic coefficient of the voltage of the power supply network. Proposed method is based on the formulation of a quasi-sinusoidal signal, and the essence of the method is to represent the original sinusoidal signal by piecewise, stepwise approximation. In this case, the harmonic coefficient of such a signal is determined by the number of approximation sections. The more approximation sections and lower the harmonic coefficient, and it asymptotically tends to zero depending on the approximation method. Improving the technical characteristics of the electrical signal generator in terms of the range of harmonic and harmonic composition is achieved by replacing the quasi-sinusoidal signal with a step signal. And now we will calculate harmonic coefficient of the synthesized step signal and find the relationship between the parameters of such a signal and the parameters of the step. In this picture, we can see half the period of the synthesized piecewise step signal, and it introduces our designations, phase coordinates of switching points of the synthesized step signal, and others. Also, other switching points of the signal. And in this case, our step signal anti-symmetric, so it has no even harmonics. In the technical implementation of an electrical signal generator by this method, it is necessary to achieve a uniform arrangement of our levels F. After conducting interim calculations, we can write a relation for the harmonic coefficient, as can be shown in this formula on this slide. Also, we can, after transformations, represent this formula as shown in formula number 8. After substituting obtained relations into other formulas and subsequent transformations, we get next formulas, 13. Then we introduce integral parameter in formula 14, and then we write expression 13 as follows, and we get expression 15. So we can see that formulas 13 and 14 are transcendental with respect to required values of the optimal values of the switching points alpha, which provides the minimum value of the coefficient of harmonics of a piecewise step signal for a fixed number of approximation intervals. This allows to find the optimal numerical solutions, and we can transform our previous calculations, and after substituting formula 15 into it, we can get expression for the harmonic coefficient as a function of our parameter beta. In this picture, we can see a dependence of the harmonic coefficient on the introduced integral parameter beta for a different number of approximation intervals p. Analysis of the graphs of the previous figure shows that harmonic distortion function tend to minimum with coordinates which are shown here near the point beta. We note that with an increase in the value p, parameter beta tends to value 1 divided by 2p asymptotically, When considering the limit under the condition p much more than 1, our formula 15 will have the next form, as we can see here. And the minimum value of harmonic coefficient will be calculated by this expression. Analysis of obtained relations 15 and 16 and the graph built and which is shown in previous slide, we can see that the change in the values of variables b leads to new different, including given values in the harmonic coefficient. For example, decreasing parameter beta from its optimal value to 0 leads to a shift of the switching points to the mark alpha equal to 0. In this case, the vertex of the resultant piecewise step signal has a longer linear section, and the signal will tend to meander shape, and beta will be equal to 0 if all switching points merge into one alpha equal to 0, and then the harmonic coefficient can be calculated by this formula, and approximately will be equal to 48%. And the result obtained corresponds to ordinate of the intersection point of the family of curves presented in previous slide, which confirms the adequacy of the proposed method. So the proposed methods of digital synthesis of electrical signals with a normalized harmonic coefficient makes it possible to calculate the characteristics of generators with the required parameters. So thank you for attention, and I will be gladly answer your questions.